Last time we learned inheritance in Java in a quick overview. Today we will go over polymorphism. This again we will be comparing Java and C++, but our focus is Java. So polymorphism, the fact that let's visit quickly or some of the code we have seen last time. We have an employee class, right? And we need to add manager. So we think this is the right way to do and extend and make the employee as a base class and use manager as a derived class so we can inherit everything currently existing employee class has. Then later on what we have done is because this manager class has bonus parameter, we added bonus and the constructor as initially 0, and then later on we add our own function set bonus, which employee doesn't have, and get salary we need to override. If you look at this side, the just returns the salary, but we need to do what? And we add the bonus onto the base salary to get the total salary of manager. So after this reminder, let's go this one. The fact that an object variable such as the variable e can refer to multiple actual type is called polymorphism. So when you have a variable e, it can refer to, at this case, an manager or an employee. But which function to be called? Automatically selecting the appropriate method at runtime is called dynamic binding. So this is not a static binding, dynamic binding. How about in C++? How we are doing this dynamic binding? In C++, we need to add, qualify a function with virtual keyword in order to do that. In Java, dynamic binding is the default behavior, so you don't want the method to be virtual. You tag it as final if you don't want to make it virtual. So how to decide polymorphism? The ISA rule states that every object of the subclass is an object of the superclass, right? We know. For example, every manager is an employee. Okay, thus it makes sense of the manager class to be subclass of employee class. We mentioned this before. Employee class here, and this manager is an employee in the UML class diagram. Another way of formulating the ISA rule is a substitution principle. So the principle states that you can use subclass object whenever the program expects a superclass object, because subclass is always has already whatever the base class has, right? So for example, you can assign subclass object to superclass variable. So this is an employee, which is the base class. We can say new employee. This is okay because employee is an object. Employee, this is new manager, is okay because manager is an employee. So this is okay. Variable type describes what it can do. This is so important. In C++ also, variable types, or in this case we are calling these are variables, but actually under the if you like to use the C++ term, these are pointers. So pointers type, or pointer is a variable, right? Type define which function to call. So if the pointer's type is manager, in this case is manager because this auto keyword automatically makes this manager. But if I call get salary, it will call automatically the manager's one. But if it is an employee pointing this one, the stuff this time, but stuff is an employee. And okay, let me rewind back a little bit. So let's study this code because I jumped this one. New employee, we created 3 stuff. This is an array of variables, but they are not actually pointing to any object yet. So these are like a pointers, not pointing to anything. But when I say stuff 0, the first one will point to the manager, or refers to the manager. And 1 and 2, this is the second and third employee. They are, variables are pointing to the employee object. So let's go over this one. In Java, every variable has a type. Yes, the type describes the kind of object the variable refers to and what it can do. For example, stuff I refers to an employee object, so it can also refer to manager object. So we will see in our code. So the question comes, there's one, let's try to answer this one. When we create a new manager, there's a boss, and we create a new employee, this is actually, there's one. But this time I implicitly put employee and manager, so it will be easy for us instead of using var and for learning purposes. So this boss is stuff. This is employee originally, this type of the stuff. So in this case, the variable stuff0 and boss refers to the same object. However, stuff0 is considered to be an only employee object by the compiler. Why? Because of the type. Can I call setBonus method with boss or stuff variable? Like I would like to do this, or I would like to do this. Which one can work? So this is okay because this first one, because the boss is manager and then it has set bonus, but this one is an employee. Employee doesn't have set bonus. This is not okay. It will give us an error. So one more iteration. Type of the pointer determines which functions are available to call. This is so important. We need to understand this. Type of the pointer. So if you want to use an object in full capacity, so you need to cast it. This is not recommended, but there is a way to do that. For example, in the above code, the stuff array had to be an array of employee objects, right? Because some of the elements were regular employees, we would need to cast the manager element of the array back to manager to access of its new variables, methods, etc., or bonds in this case. So if you look at here, stuff0, we know it is pointing to boss. So I can cast into the manager, but I cannot cast this one, right? Why? Because stuff1 is an employee. Employee is not a manager. I cannot do this because of the hierarchy. If you assign superclass reference to subclass variable, you are promising more. That's okay. Then you must use a cast so that your promise can be checked at runtime. So this can cause class cast exception, and one exception can crash, terminate your program. So for that, you want to what? To cast it. But before casting, you can use this operator called instance of. You want to make sure this is instance of manager, then you want to cast. If it is not, for example, in this case, it's not going to be true, and it won't happen. So we don't get class cast exception at first case. So we don't need to catch it on anything because we are making sure it is a manager or not. So it is again best to minimize the use of cast and the instance of operator. Beyond code exception can terminate your program, as you know. So design hints for inheritance. Place common operations and fields in the superclass, right? Use inheritance to model is a relationship. Don't use inheritance unless all inherited methods make sense. This is important. I'd like you to, pause this video and think all of them should make sense to you because it is loaded. So don't change the expected behavior when you override a method. Use polymorphism, not type information. So abstract class we will continue in our next video.